Okay, let's get started here. My name is Martin Burrows from Symetri, and my role here is to be the host of this sponsor talk. As the host, I will make sure to be a timekeeper. Also, I'll keep track of the chat and Q&A sessions. So if there are any questions, please post them in the chat and Q&A. I would like to introduce Niklas Strannefors from Bimfire Software. You're a trained building engineer, but I think you do a better job of introducing yourself than I do you. We're very happy to have you here, Niklas, and please go ahead.
Thank you, and I will start sharing my screen. Screen one. Share. Perfect. Hi and welcome to this webinar. A little bit short about me. I'm a construction engineer, as Martin told you, and I've been working with BIM and basically BIM software professionally since 2010. I've been working at the architect firm for 3 years. I worked as an Autodesk reseller as a consultant for approximately 6 years, where I worked with architects, construction engineers, municipals, and different kind of stakeholders within the AEC industry. And for approximately 2 years ago, I started at Bimfire Software, helping develop these tools and this philosophy and this method that I'm going to present to you today. And the background why we did it. The fire safety engineers had their digitalization quite recently. It's not that long time ago. Traditionally, people actually print sheets that the architects, the electrical engineers send by email as a PDF. So they traditionally just printed these, and with a marker, just started drawing on top of these kind of sheets. Not everyone is working like this today, but there's still a lot of fire engineers who still actually work like this. And what they did approximately 5, 6, 7 years ago is they actually stopped printing those PDFs and started redlining on top of those PDFs and sending it back. So they basically took the same methods that they did on the printed sheets onto the PDF and worked the same way. So this threshold going from working on the printed sheets to the PDF were quite small, and it weren't that difficult for them to change workflow. And especially when we have a discipline, a stakeholder who drawing on physical sheets, and everyone is dependent on this discipline, it's kind of strange that they didn't get further into the digitalization sooner. So we started thinking, how can we get this discipline, this stakeholder who are basically last in line, one of those discipline stakeholders that are actually last in line. We wanted to have the same low threshold as they had when they went for the printed sheets and the redlining PDFs. We wanted to have the same low threshold. So we was focusing on the number one, and it was the recognition factor. They should feel that what I'm doing right now, creating what we saw the future was creating a fire safety model. So the fire engineer should say, this is kind of how I worked before, but I get a little bit more. So they could recognize their workflow. And the same way was the work process, meaning they shouldn't change the entire way they are working when they went into working with a model, in a model. So the process, how they deliver or showcase this information should be the same. And especially, this was a quite quite difficult, but there's a challenge is that having the delivery that are basically the red-lined PDF or printed sheets, the delivery should look the same. Even though we knew we could make this process way smarter, maybe even a little bit more efficient, but the delivery, the sheets that they're going to deliver would look quite differently. So we need to still focus on having the same kind of delivery as before. So that was the challenges we had trying to change the fire safety engineer. But they are not the only one in a project. So if we're going to change the fire safety engineer workflow, well, deliveries, we need to also convince the other stakeholders. Because one of the challenges when we are changing the delivery methods and how we can interpret data, the stakeholders who are going to receive this information can't be afraid of having this new information. It shouldn't be a hassle for them. So what we also had to think about was we don't want any of the other stakeholders to change basically nothing of their current work process. They should work exactly the same way as before. So you don't want to go into a project and tell the architect, tell the mechanical engineer, you should change how you work today for this, because that's going to work better for us. We want them to do the same, and we will try to fit their work process. So the interruption wouldn't be that great, or wouldn't be that big. And what another question was that a lot of other stakeholders were talking about is the quality assurance. And with that I mean, they always had a questions, are you going into my model? Are you going into my data? It's always my, because they have the responsibility of that data historically. So somehow we need to, as well for them, explain and convince them, not convince perhaps, but explain that we're just sending information on your components with a click of a button that you can use on your sheets, that you can use in your day-to-day work. So both having a low threshold from one of the few last stakeholders that are still in the physical sheets, and still convincing those who are in the front line how they can use the data and it won't change their work process. Because for instance, one of the big challenges for energy simulations within most softwares are that they have to have certain specific ways how you build your model for this simulations to work. And it's quite difficult. That is why not that many architects are actually using these software. A few specialists are using it, but it's not that wide. We want to hit the wide market for every project, for every architect. And especially when we are delivering our deliveries, we want more from the same. So when we send those PDFs, so to speak, we want more from the same look and more from the same deliveries. And what does that mean? I have broken it down into two different, and the first one is a made-up word that we like to use, and it's the direct value. The direct value you're going to focus on is basically the fire resistance for door, detail design, and clash detection. The fire resistance on doors and windows and walls are usually looks like this. You can see some lines that represent the compartmentation for walls. If we go to the Norwegian market and the UK market, we can actually see that it also symbolizes the material requirements on that wall, the reaction to fire. And we have some text or circles or symbols that explains the physical fire resistance on this door, or if it should have an automatic closure. This is something that are sent by the physical PDFs, and the architect manually enters on each object. And of course, to start early, And in best case scenario, you could have a DVG that you could link with just lines symbolizing this compartmentation for walls. Otherwise, the architects draw this on their sheets manually as a line and mark these or enter these values reading from the fire documents. So this is something that they actually do in each project. And it takes a lot of time. And of course, there's always some uncertainty when you're reading a document, and hopefully can rely on some PDFs that something goes wrong or misinterpreting something or simply miss. So this is for the first direct value that we would like to call. This is something that they're going to use straight away, just linking the model. The next step is detailed design. What it means with this is, as a fire engineer, I like to say we need to create more drawings. And not saying that we just need more drawings to have more drawings, because that doesn't make sense, but we need to actually follow the other disciplines and create details showing what we mean with the different kind of requirements. So this is a very common requirement that which you could have a storage under a stairs. In this case, is some technical room under a gym. The thing is, when you have here, you want the fire compartmentation under the staircase. And as a fire engineer, always printing those PDFs or having those PDFs is mostly floor plans. Once, of course, there's some critical sections that are delivered as well from the other stakeholders that we can use. But this staircase would not be one of those critical sections for sure. So this would be, you would have your fire documentation telling the architect, the construction engineer, you need to have some fire resistance on the staircase in this room, this staircase. Tell us when you've done it. But by being able to create your own section from your own model, using the other stakeholders' models to create these, we can actually explain more detailed what we need and what we have, which is basically what every other stakeholder do today. And by also having an actual physical 3D model that we can use, the other stakeholders can now actually use our model for design decisions. For in this example, what I've done is there's some apartments. We got some ducts going through the different apartments, and the mechanical engineer can easily use what I like to call clash detection, and not in the traditional way of talking, where you want to check if is our ducts colliding with a frame, structural frame or structural beam. We need to go around these. Can we fit all our ducts and pipes within this shaft? No, I'm meaning here with clash detection is actually, okay, we got ducts. Do we penetrate any fire compartmentation? And have we put a fire seal around this? Do we have a damper around this? How much fire seal do we need? Could also be if you have pipes, because most pipes are plastic. If you go through a compartmentation, penetrated compartmentation, can't really have plastic. You need to change at that part at least to different material that don't burn that easy. So you can use the fire safety model to find and check all this kind of penetrations and do some and fix it basically in the design phase before going out in the construction. And of course, this is what they usually just look at the architect model and try to figure out where it is. And of course, because it's just lines, most of the cases, we can't really automatically check this. But having a 3D model, we can actually use Solibri or Navis work and have rule sets for just this. Then we have those indirect values, what I like to call the indirect communication, because a lot of information that we are putting in the fire documentation and sending to often the architect is actually used by third-party disciplines. The simplest, so to speak, and one of the hardest parts is the door specification sheets. In this is not only the fire safety engineer, this is also the security acoustics that enters a lot of information on each door, putting those requirements. So the entrepreneur who actually buys the door or the door specialist who enters all the different door fittings, the door magnets requirement, the re-enter, types of lock, and so on. Instead of having basically the floor plan PDF with the tag saying this is the door, you can see this is a door for the technical room, and the door specification sheet with that specific door, having those schedules as you can see here, and reading the fire documentation, the acoustic documentation, the security documentation, and entering all these different door fitting that fits and that approves all the requirements from the different stakeholders. This is not a smart way of working, but this is how the industry looks and works. So how can we just enter the information straight on the architect model, and they can have the requirements and adding those door fittings that fill our requirement as a fire engineer. So it makes it possible for us to actually send information to third-party stakeholders. We have the technical installation. This is the green one that you can see here. It's a traditional green for evacuation route. And this, of course, works for several different stakeholders in the evacuation plan, of course, showcasing that here is the way, this is the route that you're going to need to evacuate. This is the strategy. But it also tells the electrical engineer that in these areas, we need to have a higher fire-resistant cables, because if in case of a fire, they need to at least work for 30 or 60 minutes. And cables, as most of you people know, aren't really drawn in a 3D model. They're just some connection to have some electrical calculations. But here you can actually check that those objects, those between those 2 points that goes in and out in these kind of spaces with this kind of requirements fulfills it. And you can use it on the construction site to have the quality assurance as well on site, checking off that we have actually put in a fire resistant cable on these areas. It's a very common problem. Then we have the quality assurance. If you have any fire engineers, you probably recognize this kind of work, where we actually have, what we usually do, if we have 2 PDFs, best case scenario on 2 screens, but nowadays probably on 1 screen, where you have the PDF from the electrical engineer on the left here, and you have your fire safety drawings on the right, and you go through and check, okay, I have put the evacuation route, evacuation sign here. Have the electrical engineer put and signage on their drawings. And this is what they basically do. Check for each sign on each PDF, going through this. And what the fire safety engineer is trying to do is actually working on overview on a scale of 1 to 200, 1 to 300, while the electrical engineer, because you can see they have a lot more information, they're working 1 to 50. So you have to jump through a lot of different PDFs in the electrical engineer, while you have one and the same for the fire safety engineer. So it's quite easy to miss going through all these. But being able to have a 3D model with a 3D component, we can actually run a check that this signage is in this room. Have the electrical engineer put a signage here. The first and most simple would be just to check if there is a sign there. Later on, I don't think the industries are there yet in those projects that we are involved, but later on would be the same easy to check, is the correct signage. And this would make the quality assurance in each project, I would say, a little bit better, a little bit safer. So this is a few things that we can use, just having a fire safety or a industry that puts requirements on other stakeholders within each project into models, because some things are good as information and some things are good as components. And having these different, the last in line in each construction phase, construction project, well, building project, this will be much easier than to quality assure the entire project. And that was the last that I was planning on talking about. I'm a little bit fast, sorry about that, but have it come in any questions, Martin?
No, actually not today. There's still possible to type some in either in the chat or the Q&A. But there were one or two questions yesterday that I feel are relevant in this crowd. The first one being, which country standards are currently supported out of the box?
Currently, we have the Swedish, a Norwegian, a United Kingdom, and a United Arab Emirates version, and we are working on a Finnish version at the moment, and we're going to release it hopefully before summer.
Excellent. And the other question was regarding some of our customers that work with BIM Door Manager there, if there's some integration there. Yeah.
This is a yes and no question. We don't have a direct connection with BIM Door Manager, but the BIM Door Manager actually reads information from the architect model, meaning that it's possible for us to send the information to the architect model and then upload that information into BIM Door Manager. So it's a yes and no question. It's possible, but not direct.
Then also, thank you very much, Lars, a little bit on the cooperation with Symetri. Our role as Symetri in this is that we are the exclusive reseller of Bimfire tools, so that if you need some price quotes or anything like that, then somebody at Symetri is the right person to talk to. And there are different people with a responsibility in different countries, so it's difficult to say right away who is the responsible just for you. But if there are any questions about that, you can get back to me or some colleagues in the country that you work in. As an exclusive reseller, of course, we have a lot of partnership with Bimfire Software, and we give training and services and support ourselves, but also we receive a lot of support, and we have a lot of interaction, I would like to say, with Niklas here and with his colleagues, Fredrik and Filippa being some of them. Is there anything you want to add to that, Niklas?
No, you explained it perfectly, I would say.
Then there is one more question from Timo there. Is there some individual tools to shout out at? Yeah, the presentation talked a lot about the whole process, but are there any like individual tools that you would like to raise here, Niklas? Possibly Bimfire tools would be one of them.
Yeah, the Bimfire tools would actually, that's the tools that we're working with, and it's a tool that is a plugin within Revit, which makes it possible to keep track and send information between models. Everything baked into the the Revit model, so you don't have to send anything extra except a free plugin for the other stakeholders, the receivers of that information. And what's really good when you actually have a connection to, for instance, a wall. You want to send the file compartmentation for a wall into the parameter on that wall, meaning because we have the connection, we actually can check with some audit trail functionality if that wall have moved, been deleted, meaning a lot of fire engineers and acoustic and security engineers, they get a new drawing 2 months later and need to find everything that's changed. So these tools help keep track on what have changed, kind of like BIM 360, but in a, I would say, more simpler way, but not as beautiful with the colors and 3D view.
And then to be a little more precise on your contact persons, Paul Hove is the right person in Norway to contact. So if you're a Norwegian contact, Paul is the right person. I am the right person in Sweden. Jyrki Pietsalo is the right person in Finland, and Henrik Munk Madsen is the right person in Denmark. So then, Niklas, we really appreciate your time. Thanks for sharing this information with us. And the next step for you guys is that there is well, for everyone in this session, is that there is a new breakout at 12 o'clock, and the breakout that I'm going to be at, and I know Filippa is going to be in that as well, is the one from global to local. How do we prepare our cities for a flexible future? But of course, there are other good presentations as well, but that's the one I'm going to be in. Right. So thank you very much, Niklas, and thank you everybody else for listening. Goodbye.
Bye.